just want to do that.
And Ken, I was muted, or I was distracted earlier. Did you mention that we have various raffles?
I have not yet, but I will. So, all right, so we're recording now, just so everyone knows. And I will post this to our YouTube channel. Tomorrow morning, I'm taking my other son to grad school in Pennsylvania, so I'll be on the road for a couple of days, so probably Sunday or so, I'll have the recording posted, unless I squeeze it in before then. And I'll post the link to our Slack channel, but you also can find it on the YouTube channel. Okay, so as Brian was saying, just a heads up, we have, I believe, actually 2 book packages for Alex's, the DynamoDB book, which we'll give out later in the talk, maybe around 7 or so, and also a couple of Amazon gift cards for $25 in AWS, I should say AWS credit gift cards. I remember once I signed a survey or something and I thought I was getting AWS credits, and they actually gave me an actual Amazon gift card. I said, oh, I can buy a real thing with this. That was exciting. So these are AWS credits. All right, any other questions, announcements, or anything before we get into our main event? Fantastic. Well, thanks everyone for joining, and especially thanks to Alex. I'm not sure if anyone knows here, Alex. I guess mostly I'll let you introduce yourself, but he's a AWS data hero and the guy for about DynamoDB. He's a recent author of the DynamoDB book, which is extremely popular and very, very highly regarded, I would say. And from everything I've seen from anyone talking about it ever. So that's fantastic. And I'll also say that I actually first met Alex not even knowing who he was, really. He also works for serverless.com, the serverless framework. And I actually had an issue. It turned out to be sort of an internal bug, a small thing. And Alex was the guy that eventually got the ticket and worked with me through it. And you were fantastic. I was so delighted. I was getting like real answers, and finally told me, I think there was like a setting on how to like turn off some of the super noisy debug that was, and I was like, it was a great experience. And then I said, oh, you're the same guy that, does all this other stuff. So thanks, multifaceted.
Thanks, yep.
So with that, Alex, let me hand it over to you. Feel free to run this however you like in terms of questions during, after, in between. Introduce yourself and just let's have some fun. And I'm sure we're going to learn tons of stuff about DynamoDB and indexes.
Perfect. Cool. Thanks for having me. I will share my screen. I would say in terms of questions, feel free to ask anything during, stop me. I tend to sort of get rolling and talk kind of fast. So if you miss something, don't hesitate at all to stop me, because I'm sure someone else is thinking the same thing.
Alex, before you go any further, I'm going to, since I'm not very good at this stuff, I'm just going to hit the mute all button. Okay. And then you'll need to unmute yourself, I think. And anyone else can unmute when you need to, but this will just avoid some background noise. So.
Perfect. And then also, could you let me screen share? It says host disabled, attendee screen sharing.
Maybe.
So either make me host or enable that.
So let's see. Fortunately, you have a name that begins with an A. It helps me find you well. Except new people joined, it's moving the screen. Okay.
You can make me host. That'll work, yep.
Make host? But no, I don't think I want, Brian.
Yeah, actually, because we still have people coming into the waiting room. Ken, if you go down to screen share, and you've got, as a host, you've got an option to allow other people.
Brian, I had almost taken over the AWS Boston Zoom call, and you ruined it for me. I was going to be the host all the way from Omaha.
Well, you're the man. All the way from where are you?
I'm in Omaha, Nebraska.
Okay, I thought you said, for some reason I heard Milan, which is one of my favorite.
That would be more exciting.
Alex, do you have the ability to do it now?
Yep, I do. Yes.
Okay. I'm going to be type rated in Zoom now. Okay.
Nice. So one thing also I would say, I don't have the chat open because I only have my laptop here. So if you do have a question, seriously, just unmute yourself and then say stop and I have a question. I'll be happy to answer those. So Yeah, thanks all for coming. Before we get started, I just want to talk a little bit about Dynamo, how I got into it, what I love about it, what's sort of interesting about Dynamo, because I think it is so interesting. So the reason I got into it, and I think the reason a lot of people have been getting into it over the last couple of years, is it's a very serverless friendly database. So, DynamoDB came out in 2012, and it was used for like really high scale applications, a lot of like Amazon.com stuff, shopping carts, or other really big applications, Ubers, Lyft, things like that. But it hadn't really trickled into the mainstream as much, I think, until AWS Lambda came around and shot that up. And the reason that people started choosing DynamoDB with Lambda, with serverless, a couple different reasons, but the big one was just how the connection model of sort of traditional relational databases worked with tools like AWS Lambda, where if you had all this ephemeral little compute spinning up everywhere, trying to connect to your database, it was hard. You had to put your Lambda in a VPC, which had some bad side effects. Also, you'd hit connection limits on your relational database instances. So it was a bad fit in a lot of ways, but DynamoDB worked really well. It didn't have these connection issues because it's all HTTPS and it uses IAM rather than VPC for sort of locking that down. So that worked well. It also fits pretty well into the provisioning model of how you provision your AWS Lambda functions. A lot of people use CloudFormation or use tools like SAM or serverless framework that are on top of CloudFormation to provision their Lambdas. And Dynamo, you can provision really well with CloudFormation as well. And you can provision an RDS database with CloudFormation, but then you sort of outside of CloudFormation have to set up users and tables and indexes and all that stuff. Whereas with Dynamo, you can do that all in CloudFormation really great. Likewise, the permissions model, if you're using SQS, SNS, any other AWS service in your Lambda function, it's the same thing with DynamoDB. You're using IAM permission. So it's a familiar pattern rather than sort of having two different permissions models, one with AWS services and one with your relational database. So I think that fits really well, and that's why it's really picked up in the serverless world among other reasons, and why people started to get more interested in it. I think we're seeing the community really grow around it because of that. So I love that. I'm excited about it. One thing that's pretty interesting about Dynamo that I didn't appreciate at first, I'm growing to appreciate more and more, is just that it has consistent performance at any scale. And this is really interesting, and I used to say this wrong. I used to be like, DynamoDB is blazing fast, and I think that's not quite true. And I want to display this a little bit with a chart. So this is a very simple chart I made, but basically on the x-axis, you can think about your data size, right? And these are just very rough buckets, but maybe 1 gig in your test environment, or 10 gig when you're new, 100 gig, 1 terabyte as you're sort of scaling up your application. And then on the y-axis, we can think about performance, right? And unscientific here, but at the bottom you have blazing fast, and then just regular fast, and then sluggish and painful, right? And you can think about how your performance works that way. And if you're using a traditional database, I'm picking on MySQL here, but this is really true of sort of any relational database, or Elasticsearch, even MongoDB in some cases. Your performance might look like this, where at the beginning, when you're in your test environment or your application is just launched, right, and all your data can still fit in RAM and your indexes are perfect, the performance is really good. You have that persistent connection and it's working well. But then you get, somewhere down the line, and you get into 100 gigs of data. You started to get some serious usage, and it's gone from that blazing fast to just regular fast, or maybe even sluggish. And that's when you're starting to investigate, like, hey, do we need to, denormalize a little bit? Do we need to add some more indexes? Do we need to do something else? Remove some features that were kind of expensive on the database? And then at some point, you might get to that point where it's a terabyte of data. However you designed it, it's not working now. You need to figure out how to shard your database and all that stuff. And now you need to re-architect or re-platform. And that's a really painful process you have there. So that's sort of, I'd say the traditional database performance curve, whereas DynamoDB is more like this, right? It's going to be consistent no matter how big your data size is. And I think there are a few important things there. On the far left, it's not going to be it's not going to be blazing fast. It's going to be fast enough for pretty much any use case, other than, maybe high-speed Redis, caching use cases. But for most use cases, it's not going to be a big difference, although MySQL will be a little faster there. But the key there is that your performance is going to be the exact same as you go from 1 gig and 10 gig up to a terabyte and 10 terabytes of data. You're not going to need to re-architect that, assuming you have the very basic principles in mind. It's going to scale basically infinitely with no degradation, which is pretty awesome. You don't have this long-term drag behind you of like, hey, do I have to refactor or fix my database? So I think that's a really underrated point of Dynamo that I've really come to love. The last thing I want to talk about with Dynamo is they've continued to innovate. So even though it's 8 years old and even though it's doing pretty well, they're really coming out with a lot of cool stuff. And in the last 3 years, which is when I've started to get serious about Dynamo, they've had some pretty amazing things. So I just want to run through those. November 2017, this was at reInvent, 3 years ago, 2.5 years ago now. They added global tables and on-demand backup. And global tables is amazing. You can actually have like Dynamo tables in different AWS regions. So US East 1, EU West 1, AP Southeast 1, wherever. And if you update that table in one region, it's going to replicate that out to those other regions. And it's going to go both ways. So it's master all over the place, right? Every single table is your primary. And whenever you update in one, it's going to get replicated out to the other ones, which is pretty amazing. And it is basically like a click button type thing. So pretty cool thing they're doing there. August 2018, they released this thing called adaptive capacity, which is kind of deep in the weeds, hard to understand, but it's a really big deal for people, where you used to provision your capacity in Dynamo and it would sort of be equally spread across all your records. But, that's not really how your data access is, right? Some are accessed more often than others, and others just aren't accessed that much. With this adaptive capacity, they started shifting your capacity around so that it was used more efficiently. Rather than evenly spreading it, they're putting it to the places where it needs to be most used. So that was a pretty big change when they announced that. And then that reInvent came out with a couple really big ones as well. DynamoDB Transactions allows you to operate on multiple items in a single request. And, if one item in there fails, you can roll it back, just like a transaction you'd have in a relational database. So that simplified a ton of workflows there. They also added on-demand billing, which is really just nuts. Here's a database that you pay per use. You pay per read request or write request, which is just, I think it's pretty amazing that they can do that, and you don't have to do any capacity planning at all, and it just handles that for you. Works really well with Lambda.
So Alex, the adaptive capacity, is that different from the read-write capacity that you provision? I think adaptive capacity is if you are not using those cycles, it will be allocated to somebody else. Is that what you're saying?
So the adaptive capacity works with provision capacity. So not if you're using the on-demand billing, but if you're using actual provision capacity. And what they used to do, let's say you had 100 read units and it was split across 4 partitions, which we'll talk about later on. It used to be they would give 25 read units to each partition equally, even if one partition was getting more of the traffic. Now what they'll do is they'll say, hey, this one's getting more of the traffic. Let's give 50 of the read units to that partition so it can handle that. And then I'll give less to the other ones. So it used to be you have to sort of over provision to handle your hottest partition. Now you don't need to do that.
Okay.
Yep, good question.
More cost savings.
Yep, yeah, exactly. And then May of the next year, they added instant adaptive capacity, which this is even cooler. So it used to be, that additional adaptive capacity, it'd take 5 to 30 minutes to sort of change these traffic patterns. But now, it's instant. So if you have this capacity, it's totally flowing to exactly the items that you need it, and it's not going to throttle you near as often. So that's a pretty huge deal there, to the point where you basically don't need to worry about a lot of the scaling or sort of throttling issues that you used to worry about with DynamoDB. Still a few of them, but not that many. September 2019, they came out with Nosql Workbench. That was a pretty cool operation there. It allows you to sort of do your data modeling. I use it a ton because it's really useful. Shoot, I missed a slide here. I got to go back to December 2018. I added this one in late, but basically they raised the GSI limit to 20. That's global secondary indexes. That's going to be the topic of today's talk, and we'll talk about that. That was a pretty big increase back in December 2018. And then finally there, November 2019, they added adaptive capacity on individual items. So it used to be, they're sort of doing it on a partition level, but now if you have one item that's really getting a ton of traffic, they're going to go isolate that item on its own partition, give it its own capacity so that you can really handle all these things without sort of having, noisy neighbor issues or really hot partitions. So a lot of really cool stuff they've done. This is just in the last couple of years. So love it. I love that they're continuing to move forward. So with that in mind, let's get into today's talk. And this is called Getting the Most Out of Secondary Indexes in DynamoDB. Secondary indexes are a really important part of Dynamo, how you do your modeling in Dynamo. We'll talk more about that as we get in. So just in terms of overview, what we're going to do here, I like to start off, assuming you haven't used DynamoDB at all before, so we'll cover some basics, some vocabulary. We'll be going through that kind of quickly, so you will have your mind blown if you're totally new, but we'll see what we can do here. So we'll do some DynamoDB basics, some vocabulary. Second topic I want to cover is what I call SQL versus NoSQL, right? And DynamoDB is a NoSQL database, and we'll talk about some of the design decisions they made that are different from SQL, and then the implications those have on how you do data modeling in a non-relational database like DynamoDB. Last two sections we'll cover are more about secondary indexes. So we'll talk about the basics of secondary indexes, what they are, and then some best practices for using secondary indexes effectively, because that's gonna how you're gonna get the most out of DynamoDB. Who am I? I'm Alex DeBrie. Ken gave me an introduction there. So yeah, I wrote the DynamoDB book. Check that out. 2.5 years ago, I wrote the DynamoDBguide.com, which is just sort of a friendlier introduction to DynamoDB. So that's helpful if you want to go check that out. AWS Data Hero, just general serverless fan. If you want to check out the book, it's a very comprehensive guide to data modeling with DynamoDB. It's 450 pages, plus it has a couple supplements and things like that. Covers relationships, sorting, filtering, uniqueness, and then it has 5 walkthrough examples. And the examples I think are really fun. You get into like some of the complex stuff. Like one of the examples we modeled the GitHub backend. So it shows you how to do users and organizations and repos and issues and pull requests and comments and stars and forks and apps and all that stuff, all in a single DynamoDB table. So go check that out if you want to, dynamodbbook.com. And as Ken mentioned, we'll give away a few of those at the end here today. Cool. So let's get started with DynamoDB basics. Again, stop me at any time if you want to, but we're just going to cover vocab in this section and some key concepts. So first 4 vocabulary terms I want to talk about are going to be table, item, primary key, and attribute. Table, item, primary key, and attribute. We're going to show this by way of an example. So imagine you have some users in your application and you want to put them, you want to store that data. Your data might look like this. So I have 4 users here. One is myself, Alex DeBrie, and then I have 3 folks from Amazon and AWS. We got Jeff Bezos, we've got Jeff Barr, and we've got Werner Vogels as well. If we look at all this data together, that's going to be called a table. So all of my different records, they're stored together in a table. Going to be similar to a table in a relational database in some ways, but also different in other ways. You can also compare it to like a collection in MongoDB, but just a grouping of your records. If you look at an individual record by itself, that's going to be called an item. So that's going to be similar to a row in a relational database or a document in MongoDB, just a collection of data that's all stored together. You can see this here. This is the Alex DeBrie item. Now, when you create your table in DynamoDB, you have to specify what's called a primary key, and every single item that you put into your table must include that primary key. And that primary key must uniquely identify each item in that table. So you can't have multiple items with the same primary key. They would just overwrite each other if you tried to do that. In this case, we're using username as the primary key. So you can see that on the left, mine is Alex DeBrie. But every single item we put in there is going to have that username attribute on it. Now, in addition to that primary key attribute, we also have other attributes as well, and I have those outlined on the right. I have first name, last name, email. These are similar to columns in a relational database. The big difference here is you don't have to define these attributes up front. You do them, in a relational database. You're going to define your columns. You're going to say what type it is. You're going to say, is it required? Is there a default value? Different things like that. That's not going to happen in DynamoDB. So you might hear DynamoDB called schemaless, and that's true in some sense, right? So because DynamoDB itself doesn't have a schema that it's going to enforce for you, but it doesn't mean that you shouldn't have a schema in your application, because you will end up in a world of hurt if that is the case. So what it means is you have to enforce your schema in your application code rather than at the database level, because DynamoDB will let you put anything into it that you want. But just make sure you enforce that in your application code. You have your schema there, and you can store these different attributes. Each attribute is going to be typed. So you can have different types like strings or numbers, or you can have complex attributes like lists or maps or sets. So a lot of flexibility there in terms of what your items look like. So those are the first 4 key terms. I want to dive a little bit deeper into the primary key, which we discussed earlier. Primary key is super important. Again, it's the only required attribute or attributes on your item. It needs to be there. It needs to uniquely identify that item. And it's also going to drive a lot of your access patterns. So you really need to design your primary keys carefully. There are two types of primary key. The first is called a simple primary key that has just a partition key element. And the second one is a composite primary key, which has two elements, both the partition key and the sort key. So if we go back to that example we already had, this is with a simple primary key. It has just a username. That's the entire part. So it's just a partition key, single element to that simple primary key. You can imagine taking that same data and maybe including like an employer in it. And that's what we have here. So now I have a composite primary key that's made up of two parts. First, there's the partition key of employer. So if you look there on the far left, there's DeBrie LLC, that's my employer. And then there's Amazon Inc., which is the employer for Jeff Barr, Jeff Bezos, Warner Vogels. And then the other part is that sort key. So it's got two parts, the employer and the employer, which is the partition key, and the username, which is the sort key. One thing you'll notice there, if I highlight that, Jeff Barr, Jeff Bezos, Warner Vogels, they all have the same partition key, right? They're all using Amazon Inc. That's okay because it's the combination of those two elements that you need to be unique. So it's okay to have multiple items with the same partition key, and often actually you will. That's a very important part of data modeling in DynamoDB. We'll talk a little bit more about that in a sec. But as long as they have a different sort key, that's okay. Any questions so far on basic terminology, and then we're going to go into the SQL versus NoSQL stuff.
Sort keys across partitions, unique, not?
Yes, within across partitions or within a partition?
Across partitions.
Across, yep. So across partitions, you can duplicate as well, as it's just that combination that needs to be unique. So yes, in this case, there could be an Alex DeBrie username within that Amazon Inc. Partition key there. Does that answer your question?
Yes, thank you.
Cool. Yep, good question. Cool. So let's talk about SQL versus NoSQL. Before we do that, I do want to talk about what I call DynamoDB's guiding principle, because I think, you know, all databases and really like all sort of pieces of software, I think often have like an underlying principle and what guides them, what helps their design decisions in terms of how they sort of think about this stuff. I think like MongoDB's design decision would be sort of like ease of use, right? Very easy to get started with Mongo. They want to make sure about that. DynamoDB's guiding principle, I would say, you know, they don't state this anywhere, but I think this is their guiding principle, and it's basically do not allow operations that won't scale. So they do not want to allow something that's going to work when you have a gig of data but won't work at a terabyte of data. They just want to say, hey, you can't do that right now. If that's not going to work later on, you can't do it. So it kind of constrains you in that way. And that's what allows it to get this sort of performance profile, right? Where it's just going to be consistently fast at all levels. So it's going to constrain you in certain ways and to make sure that you have this performance profile. And it really prevents you from you know, it takes away your foot gun from shooting yourself in the foot there. So given that, let's talk a little bit about SQL versus NoSQL, a few things that they're doing there. One thing you really need to know about is the importance of primary keys. And we talked about the two types of primary keys. If we go back to that example with the composite primary key, you know, it had employer and username. When you're interacting with DynamoDB, almost all of your query patterns are going to be based off that primary key. So you can query off their employer, and within that employer, you can query based off the username, things like that. But if you look at those other attributes, you don't query based on those. You're not going to be querying, you're not going to be saying, hey, select star where first name equals Alex. You can't do that in DynamoDB. You need to be using that primary key instead. And we'll look a little bit more about implications and what that means as we go on here. The second thing that's really interesting about SQL and NoSQL is there's no join operation. And this throws people off, and I want to talk about why there's no join, because I think this is, you know, knowing the underlying principles, I think is helpful here. So far we've talked about DynamoDB as if it's this one large, you know, unified thing here that contains all of our items in it, but really that's just sort of the front end of DynamoDB. That's going to handle your requests. There's a request router, but behind the scenes there are all these different partitions, and there's different storage partitions that are split across different compute nodes, and these are, you know, maybe 10 gigs in size, and they're just splitting up your data across these partitions. And now if we think about what happens when a DynamoDB request comes in, let's say what somebody wants to do a put item, which would write an item into your table. You know, they give up that primary key. They say, hey, here's the employer, Amazon Inc., and the username, Andy Jassy, right? So we're adding Andy Jassy to this table. What is happening at that request router layer is they're going to hash that employer, which is that partition key, and figure out which partition it belongs to. So in this case, you know, they're hashing Amazon Inc. They're saying, okay, the hashed value of that belongs on partition 1, and we're going to put it on partition 1. And the beautiful part about that, the left side of that screen where they take in that item, they hash the partition key and find out which partition it belongs to, is you can easily scale it up. So I've added a third partition here. The thing is, that's still an O1 constant time lookup, because this is just a lookup in a hash map to figure out where that belongs. Very quick, very speedy. So, you know, if you add, 100 partitions or 1,000 partitions or 10,000 partitions, it's easily taking you from, you know, 10 terabytes of data down to 10 gigabytes of data with an O1 operation to like narrow down to the specific partition that you're going to be searching within, which makes it a lot faster. That's how they get that consistent performance profile. That's also why they have to get rid of joins, right? Because if you have joins, you have these two different tables that you want to sort of combine with data, and it's hard to figure out how to horizontally scale your database, which is what they're doing here, to co-locate that data on the same node, right? So if I have a customers table and an orders table, how do I know to co-locate that on the same partition? Because that's what I'm going to be joining on. And some relational databases allow you to do that, but it's tricky. It's very hard to do. Dynamodb basically just says you can't do that because it's not going to work unless you put a lot of time into it. So that's why there are no joins in DynamoDB. So two important things there about SQL versus NoSQL. You know, primary key, very important, no join operation. Let's talk about three implications that come out of that. Number one is you need to know your access patterns in advance. And this is pretty different than relational database design. I'd say the process for relational database design would be, you know, create your ERD, your entity relationship diagram, know your boxes and your arrows and how they all connect. And then you basically ship your ERD to your relational database, right? Like each box becomes a table in your relational database. If you have a one-to-many relationship, then you do a foreign key pointing to those. If you have many-to-many, maybe you do some different keys, or you have a linking or joining table, something like that. But you basically model your data first, and then you ask, okay, what queries do I need to write against this? What indexes do I need to add so that these joins are fast? Different things like that. With DynamoDB, you flip those last couple steps. So again, you start off with your ERD because you need to know your application, how those things relate to each other. But then once you've done that, then you think, hey, what are my access patterns? And before you start to model your data in DynamoDB, you're going to think about your access patterns. And you know, the way I recommend doing that is, you know, go through the different screens in your application and say, okay, what data do I need to fetch here? Here are my access patterns. Or if you're building like a single page app where you have just like a REST API, okay, what endpoints do I have? I have these 10 or 12 or 15 endpoints that I need to handle. Each one of those is an access pattern. Write it down and we'll figure out how to handle those. And once you have those access patterns, that's when you actually model your data to handle those access patterns specifically. So your table is sort of modeled for your access patterns rather than your tables modeled first and then you think about your access patterns. Next implication of some of this stuff is you often put all your items into a single table, which is very weird if you're coming from a relational world, right? Where you have customers and you have orders and order items, those would be in three separate tables, but there's no join operation here, so we can't do that. So instead, you put all your items into a single table and you sort of pre-join your data, and we'll see a little bit of what that looks like. But that, I think, really throws some people off. The last thing we're going to talk about here is you often have generic attributes for your primary key. So the examples I've shown to this point, we've sort of been taking baby steps, but now it's going to get kind of funky, and I'll show you what I mean, both by the all items in the single table and also these generic attributes. So let's do this by way of an example here. And let's imagine we're building a SaaS application, right? We're building something and there are two entities in our application. It's basically the user management system. So an organization, that's who signs up for our SaaS application. That's who's going to be paying the bill. And then within that organization, there are different users that act on behalf of that organization. They can change the settings. They can create objects in our SaaS app, whatever that is. So we have two entities we want to do here. I want to show what it looks like to have a single table with multiple different entity types and also have these generic keys, these overloaded primary keys here. So let's get started. I'm going to put two items into this table. I'm going to start with just the organization items at the beginning here. So in this example, I have two organization items. I have Berkshire Hathaway and I have Facebook. One thing I want to point out, two things I want to point out. Let's start off with the first one. Notice that the primary key elements have very generic names. So instead of having something like organization name for the partition key, I just have PK. So partition key, I shorten it down to PK, sort key is SK. And those are just the attribute names for those, which feels kind of weird. We're going to see why in a second here. Actually, let's talk about it, because the thing here is if we're putting multiple different item types into a single table, they're not going to share some attributes that you can use as sort of actually specific primary key element names. You can't use organization name because what is my user going to do? Or you can't use username because what is my organization going to do? So you have these very generic names. The second thing you might do, whoops, for those values, you can see in the values here, I have the prefix of each of these is org for organization, so org, hash, and then the organization name. And I have that for both the partition key and the sort key. You can see that pattern for both Berkshire and Facebook. And what I'm doing there is I'm basically saying, what's the template for this particular item? How am I identifying this particular item type? It's also going to help for sort of organizing your entities within a partition key. It's going to help with some querying. It's going to help from preventing overlap, you know, if you had similar names between an organization and the user. So you have these basically these patterns for your different entity types that describe what the primary key elements are going to look like. So we've got these organizations in there. Let's add some users in here to see what this looks like. So now I've got, again, those same organizations are still in here. I've also added 3 user items. They're outlined in red here. So within Berkshire, I have Charlie Munger, Warren Buffett. They've been added into the Berkshire organization, and then Sheryl Sandberg has been added into the Facebook organization. And a couple things to note here, again, they're using that same sort of template pattern, right? They're using user hash and then the username to indicate what user they are. Another thing to note, they're using the same partition key or PK value as their parent organization there. That's going to come into handy here. A term I want to introduce to you here is what's called an item collection. An item collection refers to all items that share the same partition key. So in this example, I have 3 items that are in that org hash Berkshire item collection. And it's very important to sort of understand that concept, because there's this operation you can do in DynamoDB called a query. And a query allows you to operate on an item collection. Basically, you have to provide a partition key, and you can sort of search within that item collection very efficiently. And if we think back to that chart I was showing about, you know, the request router, where the request comes in, it has the different partitions. That query can be very efficient because you have to provide that partition key. It can immediately, with that O1 operation, figure out which partition it needs to go to and then find items within that partition. So that's a super useful to understand that concept and to help that with modeling data. Last thing I want to show here is, notice that we have 2 different types of items in this item collection. I have both the organization item and the user items. And this can be useful here because this basically like pre-joins this data. So imagine we have an access pattern that says, hey, get all the users for this organization. And as part of that access pattern, we want to show some information about that organization, right? This is something you'd use a join for in a relational database. But again, we don't have joins here. But here, as a single request, we can use that query to get both the organization item and the user items. We can enrich those user items with information from that organization item before returning a response.
So Alex,
yep.
So the item collection, that what the red colored border that you're showing, that's still one single item, right?
No, that's 3 different items.
Okay.
The important part is that they're an item collection. It's a collection of items that all belong, or that all have the same partition key.
So it will be an organization Berkshire, then organization Berkshire and a user 1, and the organization Berkshire user 2. Those are the 3 items there. That's what.
Yep. So yep. If you can see my basically this one outlined in blue, that's the organization item. So I would say look at the sort keys and the lines between the sort keys there. That sort of identifies the different items. I'm using this the Nosql workbench to do this modeling, and one thing it does there is it collapses all items that share the same partition key to make it easier to see that item collection. You can see this is a separate item here, that first one, that Berkshire item. This is a separate one, this Charlie Munger one.
So in the case, if I execute a query which only has the primary key, it will bring in all of the items for that partition key, right?
Yeah, with that partition key, correct. Yep.
Okay.
Yep.
And the naming convention that you're using is purely a convention within the application. It's not something that the database is enforcing.
Absolutely, that's right. Yep. All those primary key, those PK and SK values, it's purely for you to help organize this stuff and index it according to how you want to access it.
Sure. Yeah.
Good question. Any other questions? This is a good sort of stopping point. We're just about to go to a new section. So any questions sort of on this SQL versus NoSQL stuff?
I had something that I learned. Sorry.
I have one quick question
about this. I was trying to, like you said, if you want to pull back just a user and its organization information at the same time, I struggled to try to figure out how to pull back 2 rows at the same time, and the syntax doesn't really let you do that until it finally, I don't know, I read somewhere, it dawned on me that you just do both queries at the same time and you just join them in code, right?
That's true. That's true. Yep, you can do 2 separate ones. There is also with a batch get operation, batch get item,
True,
that allows you to do basically multiple separate get item. A get item is an individual item that you're retrieving, and you can do multiple of those at once, and that can work. That can work well for this one. Thomas, did you have something as well?
Yeah, I had a question about the sort key in this example, matching the primary key. Is there a specific benefit to them being the exact same string, or is that just a convention you're doing?
Nope, there's no specific benefit to that at all. The big thing I would say is make sure that your partition key, you want to include something unique about that item so that they're spread across different partition. Like I wouldn't want to have for both of these, have the partition key be like organization by itself without some sort of identifying attribute, or like the Berkshire, like the organization name, because then they would put all those items across multiple different organizations within the same partition, and you'd have what's called a hot partition there.
So Alex, on the similar lines, I'm comparing this in contrast with how we store the objects on S3, right? And they recommend that you prepend the file name with a random number so that they get distributed into the different partitions. But in this case, the partition key is like an org pound or something of that sort. So do we create an imbalance between the partitions?
Yeah. Yep. Good question. So you're saying within S3, they say prepend with some randomness to help spread that across partitions, which I think is also no longer true. But yeah, that's a good point. They used to do that, and DynamoDB and S3 are very similar. The reason it's okay here, even though these both start with org hash, you would think they'd be located next to each other. But if we go back to this one, the important thing here is they're going to run a hash function on that partition key first before they look to which partition it belongs. So
that's different because S3 doesn't run a hash function.
Exactly.
That's really okay. Perfect.
Yep. So even though these are sort of conceptually near each other, they're going to run that hash function, which will split them off all over the place. Yeah.
And going quickly back to Thomas's point, like in the org Berkshire, primary and secondary, equally, my design choice could have been that the secondary key could have just been called, org or all, right? It's because it's unique within there, and that just could be it's just by convention, and whether you do them both the same, or you just pick one keyword.
Yep, absolutely right. Yep, that's a great point. And I would say the sort key, you can be a little more flexible. Like if you want to have the same value for all the orgs, like this could be just org or just all for those. It doesn't matter there because they've already been split across different partitions from that partition key, and you could use a static value there. And I've done that. I sort of go back and forth. It's mostly what you want to do there.
Yeah.
Good questions, everyone. This is really good stuff. Cool. I'm gonna keep going unless there's another one, but again, feel free to stop me. So I want to talk about secondary indexes. That's really the topic of today's talk. So now hopefully we got enough basics that you can understand a little bit about Dynamo. Let's talk about secondary indexes. And I want to go back to what I was talking about earlier with this sort of composite primary key. And I showed this, right, where you do all your querying with that primary key, but you don't query on those additional attributes. But that can be that can work for some access patterns, but not for others, right? Like if I want to be querying by an employer, this particular design works really well. I can get all the employees within Amazon Inc. very quickly. But what if I have a different access pattern? I want to access by their email, right? I have jeff@amazon.com and I want to figure out which user that is. That's not efficient as it's currently structured. And that's where secondary indexes come in. So with a secondary index, you declare it on a table. So you go to your table and you say, okay, I want to create this secondary index. And what you're doing is saying, I want these particular attributes to be the primary key for my secondary index. And then it's going to take your base table, and every time an item is written or updated or deleted in there that has those particular attributes, it's going to copy it over into your secondary index. So it's basically making a copy of your base table into this secondary index, but reshaped in a different way so that now those secondary index attributes are your primary key, and you can use it that way, which is really powerful. And we're going to be looking at some examples of why that's useful. So here, in this one, say I made a secondary index where the partition key was email, because that's my access pattern here. So I declare that. Those items are going to get copied over here. This is the exact same data as the prior table, but the big difference is now my primary key is a simple primary key, has a partition key of email. I can do a direct query against that to get a user by their email there.
And I suppose those are all just the pointers, right? Or does the data got physically copied?
No, that data is physically copied. It's not a pointer.
Oh, okay.
Yep. There's a little bit of nuance there in that you can have it copy all the data. You can have it copy what's called keys only, which would be the primary key specified for that secondary index, as well as the primary key values for the base table, but not the other ones. Or you can do a mix where you say, hey, I want you to copy this attribute, and this attribute, but not that other one. So I could say, hey, copy first name here, but don't copy last name. But it's actually going to copy that actual data over. It's not a pointer at all.
So you have a ability to do the projection for what columns copy.
Yep. I very rarely do, to bordering on never, but you can if you want to. Yep. Project different attributes.
In this table, you've got it showing employer and username. Do the attribute values come across when you create the secondary index? Should that be PK and SK as you had it in the former, or do you actually rename the columns?
Well, so in this particular example, this was when I showed sort of early on before I introduced the generic.
Okay, sorry.
I thought I made a mistake there when you pointed that out, and then I remembered what had happened. Yep. So these ones, they are named employer, but they will come across with the same names as your base table.
Okay, got it.
Good. So yeah, then you can get it by email. One thing that's interesting, and we're going to go into later, but items without the attributes are not copied. So if you did happen to have a user that did not input an email unless you didn't have that email attribute, it would not be copied over into that secondary index. This is called a sparse index, when you have an index that doesn't have all your items intentionally because of that. And we're going to show how that can be really useful for a lot of different access and filtering patterns. There are two types of secondary indexes. Last thing I want to cover here. There are a couple differences between them, but I'm going to give you the short version, which one type is called the global secondary index. I recommend this in almost all cases, just because it's much more flexible, both in terms of when you create it or when you delete it if you want to, what your partition key can be. The one downside of a global secondary index, and I'm going to show this here, is that you can only get eventually consistent reads from your secondary index. So if you query your secondary index, you're going to get eventually consistent reads from your base table, because there's some potential, there's some replication lag from your base table to that secondary index. It's usually sub 200 milliseconds, but it is real. So there's some potential that you would query that secondary index and not see the most recent up-to-date write for those items reflected in that secondary index. There's a second type of secondary index called a local secondary index. One thing that's nice about this is this can be strongly consistent. So you can opt into a strongly consistent read with this if you want to, if you really need that in your application. But there are enough downsides of it that I wouldn't recommend it. And one of the big downsides is that it has to have the same partition key as your base table, which really limits the flexibility in your additional access patterns. So if we show that employer username pattern, we couldn't do that email-based lookup because the primary key in that local secondary index would have to have a partition key of employer as well. So a lot less flexible. It also has to be created when your table is created. It can't be added later. It can't be deleted ever. There are a few other downsides. So I would go with a global secondary index in almost all cases there.
Alex, I've got a question. I think I know the answer, but it might be worth pointing out. I mean, with the secondary indexes, you're actually, as you said, doing more writing. And in many systems, that would incur a performance penalty, because each write is doing more work. But from what I've seen and read, in Dynamo, there actually isn't a penalty.
Yep, that's because of the eventually consistent nature of it. They'll drop it into a queue or something that will happen asynchronously, because the writes to that base table, they have basically three replicas when you do that write, and they're gonna ensure that two of them actually act the write before they respond to you, so they have some durability there. But then in terms of secondary indexes, they'll drop it into a queue, and that's going to get replicated out. asynchronously, that's where you're going to get that eventually consistent nature in that global secondary index.
Thanks.
For that local secondary index, there's probably a slight performance hit because that one, because it can be strongly consistent, they actually have to make sure that write happened. Though the one thing I would say is those local secondary indexes are, this is getting deep in the weeds, but they're stored on the same partition. So it's not like you're hitting multiple nodes. It's just making sure that 2 writes are happening on a single partition in that particular case. But let's not get into that. But basically, I would say not going to be a huge performance penalty for adding. Not going to be a performance penalty at all for global secondary indexes, and maybe a small one for locals.
Essentially, you're trading off space for performance, right? Because you're replicating a lot of data, which
Yep.
fine, but
yep, and you're going to pay for that too. Like you're going to provision your throughput separately for the secondary index, and you're going to pay for those in addition to it. But it does allow you these additional access patterns. Cool. So those are the basics for secondary indexes, and I want to just walk through a couple best practices for how to use them, and some things I've learned the hard way, and I think these can help you really get the most out of these secondary indexes. So the first one I would say is I would recommend using secondary indexes for sorting on changing attributes. So we got to do a little bit of backstory before we talk about what that means. Here's a table I have here. I'm not doing the sort of generic PK, SK. I'm doing a more simplified version. But imagine you have something like Zendesk, right, where someone signs up for a SaaS application, and these different organizations can create tickets within Zendesk. We have that here. What we're doing here, we have a partition key of organization name, because that's going to be someone that signs up for your application. And then we have a sort key of updated at, and that's going to be when that ticket was most recently updated. The interesting thing about this is, we talked about an item collection being all the items with a particular partition key. So I've outlined here, Amazon, this is an item collection. Now, within that item collection, those items are going to be sorted according to that sort key. So that's why it's called a sort key, because within that partition key, they're going to be sorted. And that can enable a lot of flexibility here. That's going to be in ascending order as it's shown here. But one thing I can do here, because they're sorted according to that updated at value, it makes it easy for me to say, hey, go give me the most recent 5 items from my, from Amazon or from Direct10 or whoever it is. And I can do that. That's really nice for me because it's doing all that sorting for me. But I do want to talk about one thing here is, in this example, that updated at value is going to be changing occasionally. And when you're changing a primary key value, when you're changing some element of that primary key, it requires 2 operations. It's a delete and a put. Like, you can't update an item when you change its primary key, because again, that primary key uniquely identifies that item. So it's basically like it's a brand new item. It's not updating it. You're actually deleting one and inserting another. So it's 2 operations there if you need to change an element of the primary key. And that can be sort of a pain if it's going to be an attribute as here that's sort of changing regularly. So however, if that sort of changing attribute is in a secondary index, DynamoDB is going to handle that for you. So let's talk about how I'd rather design this table. I initially had the primary key of partition name, or partition key of org name, sort key of updated at, and I had another attribute of ticket ID. I would actually switch that ticket ID with that sort key of updated at, because I probably have a get by ticket ID attribute or access pattern as well. So here's what I would do for the primary key on my base table. I would use partition key of organization name and sort key of ticket ID, because that ticket ID is not going to change. I don't have to worry about changing that primary key. And now I'd have my attribute of updated at. Then I would create my secondary index of partition key org name, sort key of updated at. And that's basically what I'm going to have, what I had shown already, right? Where it's that pattern. Now, whenever I update that ticket, I'm updating it as an attribute in my base table, but that secondary index is going to reflect that updated value and resort it accordingly. And they're going to handle that sort of delete and put operation for me, so I don't have to worry about manipulating 2 items when I'm just bumping the updated at time for that particular ticket. So that's one recommendation I have. If you have an attribute that's going to be changing and you want to be sorting on that, just do it in your secondary index there. Any questions on how that works? A little bit of the nitty gritty there. Cool. I'll hop into my second tip, which is overload your secondary indexes. So we talked about this before, that pattern of using generic primary keys, putting multiple items in a single table, and using those generic keys. That's called overloading your primary key we want to do the exact same thing with secondary indexes. So let's go back to that example we had, with that SaaS application. We've got organizations, we've got members, and we've got organization, we've got user items. Let's add in some additional attributes here, and I've outlined those in red on the right. One thing I want to point out here is these attributes also have very generic names. So when I'm creating these global secondary indexes, I'll give them the attribute names like GSI1PK, which stands for Global Secondary Index, the number of my index, because I might have multiple, and then PK for partition key. And same thing, GSI1SK. And the important thing here is, I can do this for all of my different items in a table, and they can be handling, that secondary index can be handling different access patterns for different types of items. Just like I'm doing that in my primary key, I can do that in my secondary index as well. So here I move that over. You can see I have my organizations. I've done a strategy here where maybe I want to have an access pattern where I say get all the organizations in this SaaS application. Well, in my secondary index, I give it each organization item is going to have a partition key of organizations, and then I'll have the sort key will be that organization name, and I can handle that pattern. But then I can also, for my member items, I can have a different pattern. What I'm doing here is within an organization, show me the sort key is the member created time, and I can get users by the time they were created or something like that within an organization. So by overloading those secondary indexes, I can handle different access patterns for different items, just like I did in my primary key in my table. Does that make sense?
Well, we have 20. Is this a strategy to conserve, or is there something else?
Yeah, it's a little bit of, yeah. So that's the thing. I would say this is a little less beneficial now because they used to only get 5 secondary indexes. Now you get 20. One thing I would say is like the provision capacity. If you're using provision capacity rather than on demand, that capacity is shared across all items in the secondary index. So it can help sort of absorb that into spikes. And share that capacity across these different items. I would say there's I think that's a good point. This is a little less necessary now that we have more, and especially if you're doing on-demand billing, but I still think it's worth sort of understanding some of this stuff. One thing I like about the generic keys, whether that's for primary key or for your secondary index, is it gets you in the pattern of thinking in Dynamo, not trying to do it like you would in a relational world, and understanding that those primary key values, they're solely to sort of organize your data in a way that allows you to handle your access patterns properly.
Alex, I guess I'm trying to think about this. I don't use this pattern, the overloading. And imagining myself doing it, I'm just afraid that like my code would be completely unreadable and I just wouldn't be able to keep track. I mean, are there tricks and techniques and aliasing and templates that you build around it, or
yep.
What would you say to that? Yeah,
the biggest recommendation I can give you, and I talk about this in the book, is separate what I call your application attributes. And those are things that are meaningful in your actual application, in your business logic, like organization name, subscription level there on the far right, username, role. Those are meaningful in your application. Separate those from what I call indexing attributes, which are attributes you only add onto your items to index them properly in DynamoDB so you can handle them for your access pattern. And those indexing attributes contain application attributes in them, but also these weird sort of prefixes and things like that. And then once you've sort of conceptually separated those, you can implement that at the boundary of your application. So what I usually have is I'll have like a class for each entity here. I have a user entity or a user class in my application. I instantiate that with my application attributes that are meaningful. And then when I serialize that to a DynamoDB item so I can write it to Dynamo, that's when it enriches it with those indexing attributes like the PK, SK, GSI1PK, GSI1SK for that. So I don't think about it anywhere in my application. I don't even really think about it when I'm doing my write logic, because that it sort of serializes all that for me.
Makes a lot of sense.
But yeah, it's definitely weird. And just having that strict separation, I think helps you like maintain some sanity, I think. Cool. We keep rolling. This last one I think is the most fun one. So let's talk about this. And this is where we use sparse indexes to filter data. And we talked about this a little bit before, but basically if you create a secondary index with these named attributes, any item that doesn't have those attributes will not be copied over into that secondary index. And you can use that strategically to filter out items that you don't want into that secondary index to basically pre-filter your data. And there are 2 different strategies around that. The first one is when you're filtering within a particular entity type based on a condition. So in my table, I might have multiple different entities, right? I had organizations and I had users. And in this strategy, I'm filtering within a particular entity type. I'm filtering within users based on some condition. So let's go back to that example we had, our SaaS application with organizations and users. And say I have an access pattern where I say, you know, I want to get only the administrators for a particular organization. I want to be able to do that efficiently. Maybe, you know, because maybe you could have 10,000 users within this organization. How do you find the admins quickly? So I'm filtering within that user type based on their role. So what I'm doing here is I'm adding these GSI1 PK, GSI1 SK values here. If you look at Warren Buffett and Sheryl Sandberg, they are both admins in their organizations. So they get those values. They get the GSI1 PK, they get the GSI1 SK values added to those items. However, if you look at Charlie Munger, his role is just member. He's not an admin, so he's not going to get those attributes added on there. So he's going to be sort of excluded from that secondary index. He's getting filtered out, and that's part of the strategy we're using here. Before I show what that secondary index looks like, I also want to show, look at our organization items, right? We're using our organization items. We're still overloading that secondary index, and we're using it for a completely different pattern altogether. So this version of sparse indexes works with that overloading pattern where you can filter within one type of entity based on some condition, and you can still use it elsewhere on some other entity type to handle a different access pattern altogether. If we go look at our secondary index now, I go to that Berkshire Hathaway partition and I find out there's only one admin, it's Warren Buffett. You know, Charlie Munger has been filtered out of that. So I've been able to filter that out based on that particular condition.
I just want to throw a suggestion out here. Anybody who has ever done a significant amount of work with pivot tables in Excel, this is exactly what you do in order to make pivot tables work in Excel, right? Because you can't query the way you would. You have to create a custom attribute that you can basically pull off and index it. I'm seeing the exact same design pattern here. I know that it's Excel versus, but if you want to implement this on your desktop solution, that's kind of the same idea.
Nice. That's super cool. I'm gonna look into that more. I definitely have heard about pivot tables. I haven't used them much, so that's good to know. Might be a good analogy for other folks as well.
Pivot tables don't do math in the pivot table. So if you need to combine or do any sort of evaluation, you basically have to create an index column that does that calculation and creates a, you know, whether it's a binary or a value or whatever, kind of re-indexes everything for you. And then you can use that column in order to filter your data.
Nice. That's cool. Thanks for that. Cool. So that's one strategy on a sparse index. There's another strategy that's really useful as well. And this is when you want to project a single type of entity into that secondary index. And the filter you basically want to do here is say, I only want this type of entity, but not another type. So let's look at an example here. This is a brand new example, but imagine you have an e-commerce store and you have a couple different entity types in your application. You have customers. All right, I have Alex DeBrie, I have Barry Bonds. You have orders because customers come and make orders on your e-commerce site. And you also have inventory that's just tracking, you know, what types of items you have available in your store. And now imagine, you know, someone from the marketing department or somewhere says, hey, you know, every day at 6 a.m. or, you know, every Monday at 8 a.m., whenever, I want to get all of our customers, I want to just give me all their emails so I can send them a marketing email. And if you scanned your entire table, it would take a lot of time to sort of filter through your entire table and find just the customers to send that to, because you got your orders mixed in there, you got your inventory mixed in there. There's way more of those than there are customers, because customers make multiple orders, hopefully. So that would be an expensive operation. So what you can do here is use that sparse index again. We'll just add some attribute to our customer items only. So only our customer items get this attribute. Let's call it customer index ID. You can call it whatever you want here, but usually if I'm doing this sparse index pattern, I'll give it some more specific name rather than that GSI1, GSI2 PK, because then this reminds me not to reuse it for something else. So I have this customer index ID value. I can put whatever value I want in there, because the big key is I just want to make sure that these get included and scooped into that secondary index. If I look in, notice that order, sorry, getting some feedback there. All right, cool. Good. So then orders, inventories, they don't have this attribute at all. If we look at that secondary index, now you can see only the customers have been replicated in there. I can do a scan against that index directly and make sure that I did. Man, can you mute? Somebody mute Emma. There we go. Thanks. Cool. Yeah, so we have this secondary index that has just the customers in it, and now I can scan that efficiently and send them all an email or whatever I want to do. So this is that second strategy that's saying, hey, I want to take, I have multiple different entity types in this table. I want to filter down to a single entity type so I can get all of those if I need to, and this is an efficient way to do this. So that's the second sparse index strategy you can use there.
Alex, I have a question.
Yep, sure thing.
Could you go back one slide, please? Couldn't you have accomplished the same goal without adding that third attribute and just global secondaried on the customer name?
Yep, that's true. You could totally do that as well. Like, this is sort of going back to what I was talking about with Ken, where I like to split up application attributes from indexing attributes and be intentional and specific and sort of reserve words for it. And the only thing here is maybe I said customer name, you could think customer name here, but what if I started enriching that order item with the customer name? I denormalize my data a little bit and put the customer name on the order item itself. Now those are going to get mixed up in there. I just have to know within my application, hey, I never want to use customer name except for on customers because I'm indexing it in a certain way. So you could do it, but I just like to sort of, I come from a Python background of explicit is better than implicit, and I just like to be super explicit with secondary indexing, with indexing attributes, all that stuff. The downside being you will pay more in storage costs there because you're duplicating information that you could have just reused.
Cool.
But
Thank you.
You're right. Yep.
Storage is cheap.
I think that's generally true. Storage is cheap. So I prefer explicit. But some people have tables that are terabytes and terabytes of data, and now it's getting to real money. But in my case, I think it's still just worth the sort of sanity there. Cool. So yeah, that's just a quick summary of what we talked about. Went over the DynamoDB basics, some vocabulary, some concepts around primary key there. Then we talked about SQL versus NoSQL, right? What are some of the differences in that NoSQL and DynamoDB, and what are the implications of that for data modeling? And then we talked about secondary indexes. What are the basics? How do they work? And what are some best practices for using those? So I'm happy to be around for questions. I'm also just available generally. So if you want to find me, available on Twitter. My email is out there and available if you want to find me. Check out the book, check out the guide. But yeah, happy to answer any questions. Happy to go back to any slides to cover anything, however we want to do that.
And everyone stick around for the raffles.
That's right.
I got a question about getting something, because so what we're dealing with is ranges of values. And what you've been using is examples of very explicit values where it's going to be exactly the same. And so you can index it and kind of group it and segregate it based on a very specific value. How do you deal with in DynamoDB with kind of, I want everything that's between 100 and 110 kind of an idea?
Yep. And so are you able to, I guess, narrow that down to some sort of grouping? In this example, right, this is that ticket example I had where I had Amazon, I have track 10, and then I had the sort key, which is time ranges. It would be easy for me to go here and say, I want to search within Amazon. I want everything between January 1st and January 15th, and it would get just these two items. Would that work for you here? Within X, give me everything between 100 and 110, or is it across your entire table?
It's three-dimensional, because we're dealing in three-dimensional space.
Okay. So is it exact match at least on one of those things and then between on something? Does that make sense?
Yeah. So it's literally latitude, longitude, and altitude. And that is, so we're searching for things within a box that we're defining the range of lat, long, and height.
Gotcha. And you have a range of lat long, you have a range of latitude, a range of longitude, and a range of height?
Correct. And so we're defining a three-dimensional box in space, and we want to get all of the values that are in that box.
Yep. So that one is a little tricky, and just because I want to go back to, I think this is one of the most important things to know about Dynamo. You need to figure out how to sort of chunk these into different partitions where you can really narrow your space, and you need to have some basically you want like a group by at the beginning where you said group by this and then search by something, right? This is a little tricky in what you're saying. I would, you know, just thinking comparatively, there is some stuff you can do with geo. Generally, if you're talking about just lat long, let's leave altitude out of it. But one thing people do with geo is use like geohashing, right? Where it creates, like, you can take any point on Earth and create like it's like a 12 character string or something like that. That's a geohash, and sort of hashes that have similar prefixes are generally next to each other unless you're on some border. What they do there is, you know, if you have a 12 character geohash, maybe you make the first 4 characters be the partition key, and then you can sort of search within that partition key a range of sort values to get that stuff. So you could maybe implement something similar here, although it's going to be tricky in exact. I'd say that's a tough problem.
I mean, so the thing that comes to my mind is you divide the world up into volumetric boxes, and if you essentially give them IDs that are a function of the coordinates.
Yep.
So I think, Alex, I think global secondary index might come to handy, because I think global secondary index works on all of the partitions. That's the reason it is called global. So we can actually define a global secondary index with the latitude, longitude, and the altitude, and we should be able to get all of the data by querying the global secondary index.
I mean, the global secondary index works on all the data, but you still need to have that partition key concept of how do I split it into some partition somewhere. You know, like a global secondary index can't do anything that a primary key can do, basically. It just enables additional primary keys, basically. So you still need to find a way to sort of chunk up the world into partitions.
Yeah,
like
I think this would work if we like predefine box sizes, and then as soon as we decide we want to do a box size that's half as big, right, then we have to somehow shard the partitions, right, into 8 pieces, kind of a thing. So that's where I'm kind of questioning, because we almost have to design in the segmentation that we want to be able to do. So the question is can we tolerate the segmentation?
I lost you for a sec.
Ahead of time, or is that something that we can deal with later on and just like repartition later on? I don't know.
It's hard to repartition later on, I would say, other than like you could repartition by adding a secondary index, basically just running a scan operation on all your items, re-enriching them with like a new GSI1 PK value, and then adding a secondary index to reshard them. So that's definitely doable. One thing I would say is like you sort of need to know the size you want, but you can also, you know, if you had a general range, like let's take it back to that geohash example, just because 2D is a little easier than 3D. If you maybe you made it down to like 1 kilometer square or 1 kilometer square area first, that would be sort of your partition size, and then you decide, oh, actually, you know what, I need to search within a 1 meter range. You can actually do that as part of your query. Like it's already been partitioned into 1 kilometer boxes, so like you can search more narrowly by just having more conditions on the sort key. It'd be a little harder to go the other way. Like if you partition it down to 1 kilometer, now you want to do 10 kilometers, that'd be a little harder. You could query across multiple partitions every time, do like a scatter gather, or you could just reshard it as you were talking about.
Would this be a good opportunity to use a different database and just share a primary key with the contents of, just use a separate database for doing the geospatial query and all the other data in Dynamo?
Yep, potentially. And I see people do that if they have like pretty complex filtering requirements. Like maybe you have 8 different things you can filter on, and all of them are optional. Like that's a pretty tough one for Dynamo to handle. So they might put it in another system, put all those, do the query requirements, and allow them to basically just return some PKs, and then they go to Dynamo and enrich with the full object, like you're saying. Same pattern you can do with search as well. Like Dynamo is not good at full text search, so maybe you put the search aspects in Elasticsearch or something like that, do that query to find your items, and then go enrich with the full items, or in the GeoSpace could work the same way.
That's the other one that we were looking at is something along the Elasticsearch line, and my weighing here is benefit versus, you know, ability.
Yep. The one big thing I would say just about those, like people offload them to other databases, like maybe big aggregations or like geospatial queries. And part of the problem is like those are just really hard queries, especially as you scale. Like it's just hard to do those, and that's sort of why Dynamo won't let you do them. It's just like because this thing isn't going to scale super well, or you're just going to like keep throwing more beef at it, and the speed might slow down over time. So you can definitely do them elsewhere, but make sure you're like, if you're going to be scaling into like the 10 terabyte range, like you might be running into problems there too.
Folks, before we go on, so this is great. Yeah, thanks for the question, because I think it opened up a lot of other good insights. So I don't want to cut off the discussion, but I also want to make sure we do our raffles before we lose people, because we tend to lose them.
Sure.
People need to go eat and things.
Yeah.
Alex, so you have at least one book package to give away. Did you have like some sort of trivia question or anything, or do you want to just do random numbers? Or?
Oh man, let me think if I had any trivia questions. Like, should I do a trivia from the talk, or should I just do like a random thing?
Whatever you like.
Anything you like, man.
If not, we can just ask our echoes for a random number.
I want someone to tell me one of the engineers that worked on the original Dynamo design.
So the first person to type that into the chat is who will win.
This is kind of esoteric. I didn't know if anyone knew that. You don't have to know. Let's see. Should I give people time to look it up, or should I just move on?
Well, we got one guess for Werner. This
Hello?
Akshat Vig?
Cannot be Rick.
Oops, sorry, I lost it for a second. There you go. Who said Werner?
Scott said Werner. Was it Werner?
Werner was one of the people on the so you can look up what's called the Dynamo paper, which is they designed Dynamo for Amazon.com, right? Because the shopping cart just couldn't Oracle couldn't handle the shopping cart on things like Prime Day and Black Friday, all that stuff. And Werner Vogels is one of the authors of the DynamoDB paper, or the Dynamo paper, sorry.
Awesome. So Scott, congratulations. Alex, how would you like to coordinate? Should you just
Scott, can you email me, and I will just send you a code. So I will type my email in here. If you have any problems finding me, you can track down Ken and he can find you, or I'm on Twitter. Just find me that way. But email should be best way.
Do we think there should be like a honorary mention for Chris, who said Dr. Dynamo?
I do like it, Chris. I do like it. Unfortunately, not the fastest here.
And Brian, did you say we also have another from a different contributor, another coupon for Alex's book?
Yeah. Carissa Wood, who is our Dynamo developer advocate, gave me another copy of the book. I was going to ask, sci-fi trivia, unless someone else has it. Unless, Ken, you have something else.
Go for it.
Okay, so, and this is a tricky one. In the new Battlestar, what was Starbuck in the end? Fair enough. Fair enough. Anthony Beckford said an angel, and the answer is nobody knows. But an angel is a fair guess. So Anthony, if you send email to me, I'll send you the book. We also have two $25 Amazon gift cards. Can you do a trivia question?
Oh, I'm not so good with the trivia questions. Although I should, if I have my son here, he actually is a trivia champion on local TV. But that's not going to help us. I'll do a random number. Okay, what number am I thinking of? No, hold it. I'll come up with something here.
Ken, what we've done sometime is just have Amanda do a random number, and then you pick that number out of the participant list.
Hey, Justin, give me a trivia question for nerds.
How about an author?
All right, I'm going to move us along. Alexa, give me a random number between 1 and 33.
And now she's going to say it out loud.
Random number between 1 and 33 is 19.
What happened? Jen, thank you. Well, let's see.
But
Does anyone know what number I'm thinking of?
Ken, what you can do is take that random number and just go to that element of the participant list.
Oh,
Yes.
yeah.
Oh, yeah, that's
How
right.
about
Who's
who's the lead character in Sandman, the most recent Audible book? That's a DC Comics Audible book.
Okay, we're going with Jen's. Did I miss my chance?
Jen, are any of those the right answer?
I love that James McAvoy is the actor, so that's probably the closest we've got.
All right, Daniel, send your Daniel Socher, send me an email and I'll send you an Amazon gift card. One more trivia question.
So my son came up with one, which is, where did the asteroid that destroyed the dinosaurs impact?
Chicxulub crater.
What? Say it again.
Chicxulub crater. It's in Mexico.
Chicxulub crater.
Say it again.
Chicxulub, I think it's
Chicxulub crater.
Yeah.
Yes.
Yeah.
All right.
Wow. I did
Derek,
not know
we'll you were so quick, we won't make you type it in, but you send me an email.
I'll do
And,
that.
and just a couple other bits of business I want to say. In 2 weeks, so far we are continuing our every 2-week cadence. At some point we will break down, but we're maintaining it. In 2 weeks, we're going to have my friend Craig Lubin give a talk on a device farm, which is a little off the beaten path for us. We haven't really done much with mobile. Craig is a wonderful, entertaining speaker. And so I'll have details for that shortly, and we'll put that up. And then a month from now, unless we get another speaker, I'm actually going to give a talk on Terraform versus CloudFormation.
And also, if there's anyone that's on the call now, if anyone has any talks that they're interested in giving, even if it's like a lightning talk, you just want to show and tell, talk about anything you're doing. I mean, we're flexible, right? So also, if, you could even have an architecture you want some peers to review. We can do all sorts of things. So be creative if you want to get a chance. Just ping me, Jen, Brian, make a suggestion, and we're happy to see if we can accommodate. So
I've got an exciting one for September. I haven't told Brian or Ken yet, but I've got one.
Ooh, I'm all
Okay.
excited. This is almost as good as the VP pick.
Yeah.
Short
Guys,
demo.
I have a question for Brian and Alex. Can you just quickly share your experience, or probably where do we get started to do the AWS Hero work? I mean, how did you get started, and what if I want to get involved? What's it like?
Alex, geez, I'm not sure, because we had someone, an Amazon coordinator, Safatra, contact Boston, and a bunch of us applied. She has moved on. Alex, I'm not even sure how that process works right now.
I think it's partly outreach to different meetups and things like that. It's part, I think they probably asked around internally. I think they just sort of knew me from the community. Like, I'd written DynamoDB guide, and that sort of popped up in different places. And I'd also worked with the marketing team on some DynamoDB stuff. So I think things like that, like do stuff, I'd say community type stuff, roughly. One thing I would say is they do have the Community Builders program, which is a newer one. I'm pretty sure it's called Community Builders,
Right.
which I believe you can reach out and apply for. And I think that's like a way to sort of get started with that process, introduce yourself to some folks at Amazon. So I would reach out with that.
Yeah. A good way to get noticed would be to give a talk at a meetup.
That's true.
Yeah, absolutely. Jen, you will hear something from me very, very soon.
Okay, and the other thing, we haven't done a panel discussion in a while, but those are often quite interesting. So if people have an idea for a discussion on, especially if it has some good disagreements, that can be fun.
Ooh, someone to defend SQL versus NoSQL.
Well, but you could have a 9-member panel to discuss all the various.
Yeah.
You know, I'm still trying to find a way to use the blockchain. Right.
Or ECS versus EKS, right?
Oh, now we're talking religion. So.
Yeah, here's one. Kubernetes is overcomplicated and probably is not a good thing to use in production.
Yeah, it's good. That'll start some fights. Before we move on, I just want to bring back for a second other specific, I'm happy to talk about anything, but while we have Alex, other specific more DynamoDB questions that we want to hit Alex with? I will say that in addition to the book, which everyone should get, of course, because it's great, like the other day, I was just searching on something on filtering, and I interestingly stumbled on something from Alex's online guide on why you shouldn't be using filters and why these aren't these aren't the things that you think they are. And so take a look at the guide too, because you know, we touched on some of that topic today, but I found it to be really helpful and really insightful. And of course, now I got some to-dos in my code that says, go back and remove this filter because, yeah, I get it now. I should be using an index on that.
Well, Alex, when would you say DynamoDB is not the right solution for the job?
Yep, I would say, you know, if you're working with, so I start to tell people there are 2 times when I would absolutely 100% recommend DynamoDB over all others. And one is if you are going to scale so large that you really are going to run into those scaling problems, like with MySQL that I was talking about, or whatever database. Like if that's where your application is going, I think you should choose DynamoDB for those. And I'm talking about specifically for OLTP like applications, not for, you know, like for individual one at a time record getting rather than like giant internal data warehouse stuff. So giant scale applications. I also recommend it for serverless applications because of what I was talking about at the beginning, how well it sort of fits with that, the connection model, the permissions model, all that stuff. All those, like those 2, I think absolutely use it there. I would also say you can use it for basically any OLTP application. And at some point it becomes a little bit a matter of choice, right? Like if it's a small scale app that's not serverless and you know MySQL really well, I don't think you should go learn DynamoDB just for this. Like it's probably going to work fine. A few places where Dynamo does not work well would be search. You can't do full text search. You can't do aggregation. So if you're going to do group by and counts or something like that, you're going to have to maintain aggregations yourself, sort of pre-rolled up, pre-aggregates. So that can be tricky with DynamoDB. Another one we sort of touched on is like multiple complex filter. If you have complex filtering requirements where it's like, you know, there are 5 different things in your application and they can all be optional and you need to filter on that, that can be pretty tricky for Dynamo to do, where you want to do more sort of direct lookups. You want to read basically the minimum number of items from disk to handle that. So I'd say that would be another place that doesn't really work well for Dynamo.
Hey, Alex, so I started off with DynamoDB writing direct Boto 3 code in Python. At some point I stumbled on DynamoDB. Yep.
All right, I'm in my daughter's bedroom and she just came in.
Hi.
We're painting elsewhere in the house, so.
I caught you, Dad.
They can hear you.
We all think your dad is amazing.
Don't puff up his head that big.
All right, now you can hear me. Want to tell him hi, Lainey?
Hi.
Hi.
That's my daughter, Lainey. All right, let me finish up this talk. I'll be out in a sec, okay?
We'll be done with them soon.
Yep.
Another hour or so, we'll be all set.
That's an eternity to her.
So, so I started off with Boto 3, done most stuff just directly that way. Eventually, you build yourself some little abstractions to sort of manage things like paging. And then I stumbled on DynamoDB. I used that a little bit was kind of okay. I sometimes feel like maybe I'm missing something. Are there other things that people are using for abstraction layers on top of the, at least in a Python world?
Yep, it's tough. I generally recommend just the raw AWS SDK. And for me, I think the hard part about Dynamo is doing the modeling. And you're doing that on pen and paper or in an Excel spreadsheet or something else. You're not doing that in code. And once you've sort of listed all your access patterns and figured out what your entities look like, implementing it in code is usually the easier part. Like, it's still hard, but it's pretty straightforward. So I just recommend Bare SDK usually. Mostly because like the ORM type things, I think push you into some bad patterns, like a table per entity and different things like that. There are a few out there that I think are helpful. So far, they've been mostly in the node world. Like Jeremy Daly has one called DynamoDB Toolbox that I like pretty well. But I mostly use the AWS SDK.
Okay, so I'm not an idiot for doing that.
Not at all. Although, I think it is a barrier for people. And the thing I'm most hopeful for is like the community is really starting to grow. And I think the more you get that growing, and especially you get application developers really going into it, I think the tooling around it is going to get a lot better because someone's going to come up with the right abstractions to make some of this stuff better. So I'm hopeful both on that and also just like an admin tool. People want to be able to search their data, and that's kind of tricky in single table. I think we're going to see better stuff around that. There's a tool called Dynabase from a friend of mine. So there are different things like that as the community keeps growing, it's just going to get better and better.
But it's already pretty awesome. And we've been using Amazon Connect and inserting lambdas in the middle of transitions as someone goes through a call center routing queue. So it has to go really, really quickly. And Lambda is doing fairly interesting Dynamo things. It's just so dead easy. And like you said, not having to do all the DML that I'd have to do if I was using a SQL database. It's just I will say I'm not all that great at Dynamo, but I don't have to be because it's not that hard.
Yeah.
At least for a lot of things.
I think that's the gateway drug for it too, is just like using it as like simple key storage. And it's just like, you know what, I know I'm just gonna be setting it by this key, getting it by that same key, and just storing a blob of attributes on it. And I don't have to worry about the other stuff. It's pretty nice.
Absolutely.
Well, why don't we let our great speaker go? This has been awesome. Thank you so much.
Yeah, so Alex, thanks again so much. Really appreciate it. It was a great talk. Everyone else, thanks for the fantastic questions and really good engagement. We haven't been doing surveys for a while because the results were sort of stabilized and we weren't learning much. But I will say, if anyone's got some feedback, feel free to ping us either directly. And it's not anonymous, but who cares? I can say anything. Really, feedback's a gift. So let us know how we can do these things logistically better, content, whatever you want to see, whatever it is. We want to help make this be a useful and engaging group. So please, let us know. Send us a note in whatever channel.
And let's thank Ken for his great hosting. Yay!
Nice. Thanks all.
All right, thanks
Alex.
everyone. Have a great night.
Night.